now taken the blank reading. I'll move my aspiration tube into the 10 ppm solution, tell the system it is 10 ppm and start the calibration process. It does seem an awfully long time while you're waiting for it to calibrate, but it is very quick compared to most machines on the market. You must ensure that when you are moving the aspiration tube from medium to medium, that you clean it and that you don't contaminate your next sample with the sample that you were just using. There we are, that's our 10 ppm calibration. Now to 100 ppm. And in a few moments we will perform a calibration for 3 different ions at 2 points, plus blank, and that will give us a very good basis to do some measurements. That's it, we now have our system calibrated. I'll just return the aspiration tubing to the blank, and we can now go and view our calibration. It's telling us that sodium, potassium and lithium are all calibrated in ppm. There is no calibration for calcium or barium. If we press accept to look at the sodium calibration, it's telling us it's a multi-point, 2-point calibration and giving us readings for the blank reading, the 10 ppm, and if I scroll down it'll give me the value for the 100 ppm reading as well. If I press accept, that will then take me on to the other ions and I can look at their calibration values as well. So now if I stop and come out of that, we have calibrated our machine, it is ready for use, and we can go into item 1 on the menu, which is read ion levels. And that will now tell us, for those 3 ions which are calibrated, exactly what values we're reading from the material we're aspirating up the tube. It will also tell us that calcium is not calibrated. There are only 4 ions displayed at any one time, but you can select which 4 you want by using the scroll button to display 4 out of the 5 ions. I'm now going to go back to my 10 ppm sample that I used for calibration. Just have a look and see what it's reading. We have the same 2 symbols on this screen that we had on the calibration screen. The first is our graph, which is currently showing that it's rising and going up to a stable level, and the second one is our noise, which is currently sitting as a nice dot in the middle of the screen, telling us we've got a good reading, and that is now reading 10.80 ppm. I'll return that to the blank. I'll now do the same for a 100 ppm sample of potassium. You can see here we've got a big black dot where the noise is. This is because we've just injected a lot of chemical into the mixing chamber, and it is now starting to stabilise and coming back to a single dot in the middle. We've now got a nice stable reading, which is 101.6 ppm. Back to the diluent. I'll now put in a sample that was prepared earlier, and we'll see what readings we get from that. You can now see that all 3 ions are showing a lot of noise while the aspiration goes up into the chamber. That's now dropped away to a single dot. The graph is climbing up to a stable reading. We now have stable readings of 11.90 on sodium, 10.36 on potassium and 10.51 on lithium. Back into DI. Lastly, to another sample that was prepared earlier. This once again is a mixture of sodium, potassium and lithium. This should be 10 ppm sodium, 20 ppm potassium and 30 ppm lithium. We've now reached a stable reading, which is telling us 12.20 on sodium, 21.12 on potassium and 33.91 on lithium. back into the DI. That very quickly was a 3-ion multi-point calibration with a demonstration of subsequently reading different samples to see how they show on the display. That is the machine working in standalone mode, which it does quite happily, but you can link the machine to your computer if you wish.